undertaken by our brilliant future generation, I invite Mr. Vishweshwaran J, Country Manager, Higher Education Programs, ARK Info Solutions Private Limited, to give away the Best Project Award of Samiksha. The first prize is backed by Jeevan Vargas of Kristujyoti Vidyaniketan, Chetipura.
A fully autonomous robot car. So this has six infrared sensors and seven ultrasonic sensors. So these five infrared sensors which I'm pointing out, which have this green circuit board, are basically custom designed so that they can work outdoors. Because I had to design these manually because of that. The normal sensors when we buy from online, they only work indoors. So that can cause some issues when we test them outdoors. So that reason I had created these sensors as for outdoor use, and this sensor is already for outdoor use. And if you ask me why it is like that, it's because of that infrared sensors that are used for outdoor use is very expensive. So to make it cheaper, this car, I had designed these sensors. Then let's go with the ultrasonic sensors. So these ultrasonic sensors are designed to measure the distance using sound. So they have like a maximum range of 4 meters, while the infrared sensors use light to measure the distance. So those there is not a specified range for it because I'm still doing the testing of the sensors and experimenting how long they can detect. Then all of these sensors are connected to the Arduino via these wires. So these sensors will produce a signal according to what was the object, like any object they detected, and that is inputted into the Arduino. So then this Arduino board, which is on the electronics bay, it does all of the processing and calculation of all of the sensors data, and it does the decision through the using if-else statements. So that means like what are the data from the various sensors, it uses that to determine which statement, which part of the code should be executed. And from there it sends a signal. Two signals are being sent. So one is both are PWM signals or pulse width modulation signals. So these signals passes through these wires which go to the steering motor and to the speed controller. So the speed controller is not like a normal DC motor speed controller. This is basically a BLDC speed controller. So it's a 3-phase speed controller and has 3 wires that go into the BLDC motor. So the BLDC motor, this particular model, has a lot of power and a lot of torque. So but the problem is that in between it gets stuck because of it does not have a proper sensor wire technology incorporated between the BLDC motor and the ESC or the speed controller. So then this speed controller takes the data PWM signal, that is basically an on-off sequence at a particular frequency or at like a variable frequency that the Arduino is producing. So then this frequency or this signal is then used by the ESC or electronic speed controller to change the speed of the motor. And also this Arduino does the changing, it does also the work for changing the direction of the motor. Then the next thing is that this is the servo motor of the steering, for the steering work. And then what it does is basically when we put a pulse width modulated signal, it according to that frequency the motor changes its angle of rotation. So that means how much degrees it rotates, it will rotate that much. So that means how much the amount of PWM signal we are providing, it will change. So that is the servo motor. So then basically this is a fully customizable unit, and this Arduino is connected with the Bluetooth modem. So this Bluetooth modem allows you to communicate and get live telemetry data. So that means we can receive data of the individual sensors or what is going on inside the processor of this Arduino Mega. Then what is like the battery percentage, the voltage of the batteries, then how much current is being consumption is going on. Then we can also measure the PWM signals. We can do so many things through that Bluetooth modem, and also we can also send commands. That means like if I want to turn on autonomous mode, I can also send a command, then it will from the mobile phone or tab or even laptop using through via Bluetooth. So then this Bluetooth also allows you to change modes like autonomous mode, semi-autonomous mode. That means I can control the forward and reverse control from the remote itself to the car, and the steering will be fully automated. Then I can also use the normal drive mode, which means I can drive the car like a normal radio control car. Okay, so then now this has a radio receiver, so that means like, and the transmitter. So then that means like when I put into normal drive mode, I can control from the transmitter to the receiver. So now the default mode for this one is like when we turn on and start using is basically normal drive mode, and that's I have also demonstrated that to you. This system has two batteries, and this battery in the back provides power for the all the electronics in this electronics bay. Then this battery here, which is lying down here, this battery does all of the heavy lifting work for powering the electric motor and the BLDC motor, which is inside here. Okay, and this car is a fully customizable unit, and that means we can add various sensors like GPS, then a compass sensor, and I'm actually working on that part. Then also we can add like humidity sensors, we can add temperature sensors, we can add so many types of sensors. So that means we can use it in various applications. So like there are few applications this car can be used, like is we can use it for developing like fully autonomous self-driving trucks, or like to transport goods from different parts of the country or maybe different places. Then also we can incorporate it for like self-driving cars, so that means, or self-driving buses. So that means like we can transport people much more efficiently, and this system is fully upgradable. And also any like my plan is to make it so that any company or any startup wants to like work on a fully autonomous system or want to work on a software that works, so but they need a test vehicle for that. For that reason I am developing this kind of system. So it is not only that, is to make it cheaper, so that people who is interested in this kind of stuff, they can work on making their software or adding new sensors, or their own type of sensors they can add. So yeah, and this is basically the whole it's still a development unit and still working on some of the coding for the system. And also I'm eventually upgrading the software, so that means I can like there'll be a specified app for using this system with, and also we can do so many different things, and so it's actually flexible also, this whole system. Yeah, thank you.